by using the Gauss's law, find the expression for electric field at point P for uniformly distributed charge along infinite straight line. That is the same as we have done exercise by using the electric field intensity. But now we will solve it by using the Gauss's law, and you will be observed that it is a very simple as compared to by using the definition of electric field intensity. Okay. So how we will solve by using the this is uniformly distributed charge. Okay. Okay. And at the midpoint, let's suppose this is point P, okay, where we are interested to find the electric field intensity. Okay, as I have already explained, we have to consider the electric field will be always for this case is also a radial. Okay. Also, this is because this is a straight line. This is not sheet. Okay. So electric field will be radial. Radial mean this is same as I have already explained. This is like if you consider that this is a rod, okay, this is charge, okay, so like this, electric field will be all around this. Okay. Okay, so electric field will be radial. So electric field will be radial. Okay, mean that will be make a circle. Okay. As okay, if you consider that is like a circle. Okay, like a circle. Okay. Okay. So that will be all around. Okay. So if I consider the Gauss's surface, okay, for Gauss's surface, so I may consider that point is on this sheet. Okay. No. Wrong. Yes. Sorry. If this is point P, okay, where we want to find the electric field intensity, so I will consider that there is for Gauss's surface I have to consider, because it is making a circle, field is making a circle, I will consider this is the Gauss's surface around this. Okay, मेरे ख्याल में ड्राइंग इतनी अच्छी नहीं बन रही. This is the Gauss's surface. Okay. So this is a Gauss's surface. Okay. Again, if as I have already explained, this is center and this is radius r. Okay. Okay. So if you see that there will be all field is a radial and will be passes along all the circles. Okay, so that is like a this. That is not the the previous axis, but it is along the electric field is everywhere. Okay, this electric field is here. Electric field is किधर है? आप लोगों ने जल्दी डाली है ना, तो मुझे ड्राइंग भी नहीं अच्छी बन रही. So okay, so electric field will be R side E. Okay, so that will be radius. Okay, so according to Gauss's law, E ES ds, okay, that will be equal to Q epsilon naught. Q is along the line, that will be a sigma L. Oh, sorry, not sigma. Linear charge distribution is like this along the length. If this is length, okay, L, charge will be along the line. This I have already explained. This is charge, okay, and this Q will be, that is closed by the Gaussian surface. That is mu. Mu is the linear charge distribution, that is uniform, and L. L is length of this charge enclosed by the Gaussian surface. Okay. Q is equal to mu L. Mu is linear charge distribution. Linear charge distribution. And what is the L? Length of cylinder enclosing चार्ज, यानी वो सिलेंडर की लेंथ जो उस चार्ज को इनक्लोज कर रहा है. ओके, दैट्स व्हाई दैट इज इक्वल टू दिस. ओके, बिकॉज Q is the charge, because why? Q is the charge enclosed by Gauss's surface. Okay, so that is along the line, that's why. Okay, okay, this is this length, ये जो लेंथ है ना, ये वाली लेंथ, ये मेरी बात समझ रहे हो, ये यहां से लेके यहां तक, ठीक है, इस लेंथ में यहां से लेके यहां तक जो चार्ज इनक्लोज है, दैट विल बी डिफाइंड एज अ linear, that will be the Q charge. Okay, okay, so E is also radial, and this is also radius. So that is will be angle will be always a, he is also radial, is outward, and the surface, round surface will be also a radial. E is radial, and S direction of round यानी सर्कुलर, ठीक है, सर्कुलर surface is also radial. ठीक है? So okay, so this will become E ds cos 0 equal to 1 mu L, and E this is equal to 1 ds, that will be mu L, and E will be equal to this will be a pi r square, no sorry, 2 circle है, the circumference is 2 pi r L, 2 pi r circle, the circumference of the circle, L is the length of the cylinder. So the area will become the area around the, we are not considering this surface and this surface, because here this will be this surface, this will be if this S2 and sorry, I have not mentioned that is both are making angle 90 with the radial surface. यहाँ लिख लेना चाहिए. Why we have not considered S1 and 2, because they are making angle 90 degree or pi by 2 radial along, किसके साथ बना रहे हैं, along radial field E. Okay, you have to mention. Okay, why we have only considered the round surface, but remaining all will be make a 90 angle. मैंने directly लिख दिया. ठीक है, so that will be equal to this. This is equal to mu naught L. L से L कट गया, so E will be equal to mu over 2 pi r. This will be magnitude, and E vector will be equal to mu naught 2 pi r unit vector. Okay. Achha, if I have considered the capital R, then you must write, if this is a capital R, you must write this capital R. Okay. But you have also you have to mention why this is, why this एरिया, ये लाजमी लिखना है, रीजन बतानी है, why area of round surface of cylinder is equal to 2 pi r L, because it is circumference of circle. Okay. And other is नहीं, length, because circumference of circle multiply with length of cylinder, that will be area of the circumference. ठीक है, length of round surface of cylinder. Okay, so this I have mentioned this, why this I have written Okay, so this is the again same result as we have derived for the linear charge distribution in the previous exercise, but using the definition of electric field intensity. But now I have used the I have derived this expression by using the definition of the Gausses. Yeah, by using the application of the Gausses. So it means it make our problem very simple. So you may compare it. Okay. Best of luck. I think for today it is okay. आज के लिए